Let's cover the lonely number problem. Suppose we're given an array containing a bunch of numbers. So here we have an array that looks like this. We have 1, 4, 7, 9, 4, 7, 1. The 1 appears twice, the 4 appears twice, and the 7 appears twice, but the 9 appears only once. And let's suppose we wanted to write a function that would return just the one lonely number, hence the name, from an array where everything else is duplicated. How could we do that? From a brute force perspective, how could we do this without any special tricks? What is the most inefficient way to do this? Well, if we think about just using basic loops and iterations, we clearly have to keep track of what numbers show up twice and how frequently numbers show up, essentially. What if we were to iterate through, because that's one of our only weapons per se as technologists working through this problem, but what if we were to iterate through the array and at each stop, suppose we're on 1, count the number of occurrences in the rest of the array. So, for example, in this case, if we start at 1, what we can do is iterate through the rest of the array and look for the number of occurrences of 1. So we start at 1, we iterate through, and we see that 1 appears a second time, and so we know that's not the number. Then we go to 4, and we see that 4 appears a second time. At 7, 7 appears 2 times. And then when we get to 9, we'll search throughout the rest of the array, and we'll see that it only appears once. This is, of course, brutally inefficient because we have to iterate through each number, and then at each number, we have to iterate through each other number in order to get a proper count. A better way to do this is to introduce an additional data structure. Suppose we had a hash map. We know that hash map keys are unique. What if we were to iterate through each element, and as we iterate, we set each key as a hash map key? When we get to the duplicate, since each other number appears twice, we can delete the first one. And then what will remain should be the one key that hasn't gotten deleted. Let's preemptively look at the solution, since it's easier to visualize, in my opinion, with code. We take a bunch of numbers in array format, and we can create an appearances hash. Using the appearances hash, we can iterate through each element in the numbers array. Here's the most important part. If it hasn't shown up yet, we'll add it as a key with true or any arbitrary value to the hash map. And the second time, if it's already shown up, we'll just delete that key. And then the only one that remains, hence why we can be confident in selecting the first index, is the non-duplicate number, the single lonely number. And in this case, we parse int it in order to get it in the right format. The solution reduces the time complexity from the O of n squared brute force nested loop solution to just O of n, because we only need to iterate through the input array once. As you can see here at the bottom, there's a third way to accomplish this task using bit operations and bit manipulation. We can accomplish this using the Xor Binary Operation, which stands for exclusive OR. So here's an example of how exclusive OR works. Essentially, when we perform exclusive OR on two numbers, the resulting bit evaluates to 1 if only exactly one of the bits is set. If we had two decimal numbers, 7 and 10, and we converted them to binary numbers 0, 1, 1, 1, and 1, 0, 1, 0, and took the XOR operation of the two. What happens is we only return 1 if the numbers are different. So 1 and 0 are different, so we get 1. 1 and 1 are the same, so we return 0. 1 and 0 are different, so we put down 1. And 0 and 1 are different, so we put down 1. So using the XOR operation, we can just XOR every number in the array. The reason is, if you take the XOR of a number with 0, it'll return the same number again. So 0 XOR n is n. And simultaneously, if you take the XOR of a number with itself, it'll return 0 as well. And this is really important for removing duplicates. N XOR n equals 0. So here you can see, if we had an array 6, 2, 4, 2, 4, we can reduce it to 6 XOR 2 XOR 2 XOR 4 XOR 4, which reduces to 6 XOR 0 XOR 0, which further reduces to 6 XOR 0, and eventually just 6, which is the single lonely number. And the alternate solution is here, and it's as simple as just XORing every number starting from 0.